Math. It's Friday, May 8th. So what you should be doing right now is one of two things. Number one, you should have already done the multi-step inequality review, and now you're just checking your answers and going over your work while I do them. Or number two, you are doing the video, you are watching and listening to the video while I do the problems with you. If you're choosing number two, what I'd like you to try to do is do the problem and then watch my video, not do the problem along with me, because I really want you to be able to do these on your own. Okay, but if you totally get stuck, then of course, go ahead and watch my video and we'll do it together. So hopefully this works, and hopefully you're choosing correctly. Now, if you're choosing just to copy my work, think about that. It's not helping you. I'm the one getting better, not you. You've heard me say this before. Also, this is to help you in high school. It's not going to help you in high school if you don't put the effort into this. So hopefully you take my advice here. All right, here we go. All right, so here is problem number one. So we need to solve this inequality, and we need to also follow the rules of equations are all the same. So first thing I am going to do is I'm going to put a 1 in front of this y just so that I know that there's a 1 there. I want to isolate my variable y because I don't have any distributive property. I don't have any like terms on the same side. I don't have any fractions. So what am I going to do first so that I can get this negative 1y on this side all by itself? I am going to add 14 to both sides. Okay, when I do that, negative 19 plus 14 is negative 5 is greater than negative 1y. Keep moving the problem. Okay, so what do I need to do now? I need to divide both sides by negative 1. And negative 5 divided by negative 1 is 5. Now, this is something you guys are forgetting, that remember when you multiply or divide both sides of an inequality by a negative, which we just did, we have to totally flip our sign. So instead of greater than, it's now less than. And then on the right side, we have y. Now, the second thing many of you are forgetting is once I am done, if my variable is not on the left, I shouldn't be graphing it yet. So I need to flip this over and make it y, 5 on this side. So I have to flip my inequality sign. So we're back to greater than. So this was a double flip problem. So my answer is y is greater than 5. So the way we graph that, we should have a 0 in the middle. We should have my positive 5 and its opposite, negative 5. Okay, greater than means an open circle, and then greater than means bigger. So I want to shade to the right. So there's number 1. Okay, here's number 2. And again, I would prefer that you stop the video and work it out and then come back and go over it with me. Or you should just be going over it with me because you've already done it. Okay, here we go. So first of all, we have two distributive properties, so we're going to make sure we do those first. So this gives me negative 6 times w is negative 6w. Negative 6 times 1 is negative 6 is greater than. Okay, on the right side, I'm going to do the distributive property. 2 times w is 2w. 2 times 5 is plus 10. Okay, did the distributive properties. I do not have any like terms to combine on the same side, so I need to move my variable to one side. And you know me, like always, I always go to the left, but you could go to the right if you want to. So I am going to move my 2w by subtracting 2w from both sides. Negative 6w minus 2w, that gives me negative 8w. Minus 6 is less than 10. I need to isolate my variable. So to do that, I'm going to add 6 to both sides. And I get negative 8w is less than 16. Okay, I need to solve the problem. So I'm going to divide both sides by negative 8. And of course, at this point, you should be saying, I divided both sides by negative, so I need to flip my sign. So this gives me w is greater than negative 2. Okay, so I go to graph it. I'm going to put 0 in the middle. I'm going to put -2 on the left. I'm going to put its opposite 2 on the right. Greater than is an open circle. Greater than means bigger than, so that means I'm going to shade to the right. Okay, here's problem number 3. So this is one of those, it's got a big fraction in it. So hopefully you remember when we have a big fraction, we're going to get rid of the fraction by, we're going to multiply both sides by whatever that big fraction has under it. So we're going to multiply both sides by 2. So if I take 2 times -4, that's -8. I do not flip the sign because I multiply both sides by a positive. Now, if it was a -2, I would have flipped the sign. Now, on the right side, I don't literally multiply by 2 because what happens is there's a 2 on the top and a 2 on the bottom, so the 2's cancel out, and I just end up with -6x plus 10. When we did these back in equations, I called it, we had to unlock the problem, okay? All right, so now I'm ready to isolate my variable, and it's on the right side this time, and that's okay. So I am going to -10 from both sides. -8 minus 10 is -18. Now, I do not flip the sign. I didn't multiply or divide by negative. I subtracted. That's not part of the rule. All right, so here's where I'm at. All right, now I'm ready to divide both sides by -6. Now I need to say to myself, oh, I just divided both sides by negative, so I do need to flip the sign, and the equal to is still there. So when I take -18 divided by -6, that gives me +3. Over here it's x. Okay, but before I graph it, my variable is on the wrong side, so I'm going to flip the x and the 3, which means if I flip that over, then again I have to flip the sign. So my answer is x is less than or equal to 3. Okay, so I'm going to put 0, I'm going to put 3, I'm going to put -3, I'm going to put a closed circle on 3 and shade to the left. Problem number 4. So problem number 4, we have a distributive property, so we know we need to do that first. So if I take -4 and I multiply it by 2x, I get -8x. If I take -4 times -8, I get +32 is less than 6x minus 2. Okay, I don't have any combining like terms, but I do have variables on both sides. This time, just for different, I'm going to take my variable to the right instead of the left. Totally out of my comfort zone, but I can do this. So if it's -8x, I'm going to add 8x to both sides. And I get 32 is less than 14x minus 2. Okay, I need to isolate the variable, so I need to get it by itself, which means I'm going to add 2 to both sides. And I get 34 is less than 14x. Okay, need to solve for the variable. So I'm going to divide both sides by 14. I do not need to flip the sign yet because of the fact it wasn't a -14. So I get 34 over 14. Well, I know that I can divide both of those by 2. So this is going to give me 17 over 7 is less than x. Now, again, what's wrong with that? It's backwards. I need to move the variable first to the left, and when I do that, I need to flip the sign. So it's greater than 17/7. Okay, so this one's a little trickier to graph. We've talked about how to graph fractions. If you've watched my videos, you should know this. So I'm going to put a 0, and I'm going to put a 17 over 7, and I'm going to put a -17 over 7. But I need to know, what does 17 over 7 fall between? What two whole numbers? So you can either take your calculator and take 17 divided by 7, or I'm going to do it here. 7 goes into 17 twice. That gives me 14, and it gives me a remainder of 3. So technically, 17/7 is 2 3/7. So what two whole numbers would 2 3/7 fall in between? Well, 2 and 3. So I'm going to write it falls in between 2 and 3. Back to my answer, x is greater than, so I'm going to put an open circle, and then greater than is always to the right. All right, here's problem number 5. Okay, and I notice in fine print, it says, hint, eliminate fractions by multiplying both sides by the least common denominator. Oh, okay, so that should give me a hint. So in number 5, I have no distributive property, but I have these ugly fractions, and I don't want to work with fractions. So I'm going to take this hint, and I'm going to multiply both sides by the least common denominator. Least common denominator of 3/4 and 2/3 is 12. So I'm going to multiply the entire problem by 12. The entire problem, not just the fractions. Okay, so let's do that work. So if I take 3/4 x times 12, I put 12 over 1. 4 goes into 12 3 times. 3x times 3 is 9x. So 3/4 x turns into 9x. Okay, then it says that I have to take 12 times -2. Well, 12 times -2, that's -24. And yes, because it didn't have a fraction, I still multiply it. Is greater than. So now I've got to take 12 times -2/3 x. So if I take -2/3 x times, okay, so -2/3 x times 12. So I'm going to put the 12 over 1. 3 goes into 12 4 times. -2x times 4 is -8x. Then I've got to take the 12 times -3 and I get -36. So I have eliminated the fractions like it told me to. Now I have no common terms to combine on each side, but I do have x's on both sides. So I want to take my x's to one side. So I'm going to add 8x to both sides. And remember, you can only add x's to x's. So this gives me 17x minus 24 is greater than -36. Okay, so I am ready to isolate the variable. So I'm going to add 24 to both sides. And I get 17x is greater than -36 divided by 24 is -12. Okay, I'm going to have to move up here because I ran out of room. Okay, what's next? I've got to solve for the variable. So I'm going to divide both sides by 17. Now, some people would see that negative there and go, oh, I got to flip the sign, but I divided by a positive, so I'm not going to flip the sign. So my final answer is x is greater than -12/17. Okay, so if I go up here, I'm going to put 0, and I'm going to put -12/17, +12/17. Now, think about what two whole numbers would -12/17 fall in between. Well, think about the fraction 12/17. It's not even 1. So this falls in between 0 and 1, but because it's a negative, it falls in between 0 and -1. So we just need to put our -1 here because we already have the 0. So greater than, back in my answer, so open circle, shade to the right. All right, here we go, number 6. So number 6, we do have a distributive property. Now be careful, some people back when we were doing equations would say, oh, we take -4 plus 2 first. No, we actually do the distributive property. So this -4 comes along for the ride right now. 2 times x is 2x, so we have plus, why is it not going away? Plus 2x, kept disappearing. Positive 2 times -1 is -2. My iPad's acting funny. Okay, so -2 is less than or equal to, well, let's keep disappearing. I swear I'm not trying to make it erase. And we get, I'm going to put 1x minus 6. Okay, so now in this particular problem, we actually do have two terms that we can combine on the left side. -4 minus 2 gives me -6, and then plus 2x is less than or equal to 1x minus 6. Okay, I have variables on both sides, so I need to move them to one side. So this is a positive 1x, so I'm going to minus 1x from both sides. And I get -6 plus 2x minus 1x is 1x is less than or equal to -6. Okay, I'm ready to isolate the variable. So to get rid of -6, I'm going to add 6 to both sides. And I just get 1x is less than or equal to, now -6 plus 6 is just 0. Okay, now before anybody thinks that this is, oh, it's a no solution, it's not. So I still have one more step. I need to divide both sides by 1. I do not have to actually flip the sign because it wasn't a negative. I just get x is less than or equal to, well, 0 divided by anything is just 0. Now, that doesn't mean that this answer is no solutions or anything like that. We actually are going to graph x is less than or equal to 0. So I'm going to put 0 on my graph. 0 doesn't have an opposite, so it's just going to be 0 on my number line. Less than or equal to means I'm going to put a closed circle. Less than means left, so there's my answer. All right, problem number 7. So on problem number 7, I have a distributive property. So I am going to distribute. Negative 2 times 4x is negative 8x. What in the world? Okay, negative 8x. Man, I'm just having all kinds of trouble. Sorry about that, guys. Negative 8x, there we go. And then negative 2 times negative 3 is plus 6 minus 5x is less than 2x minus 6. Okay, so now I'm going to look. I have like terms on the same side, so I'm going to combine these two. Negative 8x and negative 5x gives me negative 13x plus 6 is less than 2x minus 6. Okay, I'm ready to move my variables to one side, so I'm going to go back to my normal. I'm going to move them to the left. So if this is a positive 2x, then I'm going to minus 2x from both sides. What's that give me? Negative 13x minus 2x is negative 15x plus 6 is less than negative 6. Okay, so I'm ready to isolate my variable. So I'm going to subtract 6 from both sides. And I get negative 15x is less than negative 6 minus 6 is not 0, it's negative 12. Okay, I'm ready to divide both sides by negative 15. Okay, now you should be saying to yourself, hey, I just divided by a negative, so that means instead of less than, I need to flip it, make it greater than. On the left, these two cancel out, and I just get x. Now, let's think about negative 12 and negative 15. Well, two negatives make a positive, and I can divide these two by 3. So 12 divided by 3 is 4. 15 divided by 3 is 5. So x is greater than 4/5. Okay, so let's go to graph this. So 0, 4/5, negative 4/5. All right, but now let's think about 4/5. If you think about the fraction 4/5, that's not even a whole. So it doesn't fall between two whole numbers, it falls in between 0 and 1. So I'm going to put 1 on my graph. X is greater than 4/5, so I'm going to put an open circle, shade to the right. Okay, last problem. So what does this say? It says write an inequality and solve, and you do not need to graph. Okay, so the sum of a number and 14 is no less than, it shouldn't have a 2 there, sorry, 3 times the number. Okay, so let's think about this. A number, we don't know the number, so that would mean we need to say, let's say n is our number, okay? So if we have the sum of a number and 14, well, we should all know that the word sum means add. So the sum of the number and 14, so that's n plus 14. Now, look at this statement here, is no less than. All right, let's think about that. Is no less than. So if my mom told me, hey, you can go to the grocery store and you can spend no less than $100, that means I want to spend greater than or equal to $100. So my symbol is this, okay? 3 times the number. Well, 3 and then times the number. Well, the number is still in. So this is the problem that you should have written. Now we're ready to solve it. So there's an imaginary one here. Now this time, even though I normally take my variable to the left, I am looking ahead and thinking, well, if I take the 3 into the left, I won't have anything on the right. I don't want to do that. So this time I am going to take my n to the right. So I'm going to subtract 1 n from both sides. And I get 14 is greater than or equal to 2n. Okay, I'm going to divide both sides by 2, and I get this. 7 is greater than or equal to n. Now, even though I'm not graphing, I still don't like my variable on the right side, so I'm going to write this as my answer. N is less than or equal to, because I got to flip it over, 7. So that means whatever the number is in this problem, it has to be less than or equal to 7 to make this problem work. So that's my answer to number 8. Okay, so at this point in time, you should be done with the assignment. Please submit your assignment, and it should have a bunch of work on it, because obviously you've seen mine. I have a bunch of work. And then you're done for the day. All right, have a great weekend. We only have one more week. Crazy to think about, huh? See you later.